Good morning. I am Manikesh Kumar, working as an assistant professor in ECE department in IIMT College of Engineering, Greater Noida. So today we are going to discuss about the basics of signal systems. So first of all, the signal system is the most important subjects in the ECE departments, Electronics and Communication Engineering departments. So today we are going to discuss about the basics of the signal system. Means we are going to discuss basic of signals, how many types of signals, different type of signals, and the basics of system. What are the systems which is existing in these signal systems? So first of all, we are going to discuss signal. So first of all, what is signal? So signal is a function of one or more variables that conveys some information. It means signal is that which gives you some information. It may be one variable or one-dimensional variable or multi-dimensional variable. So what are the examples? So example of the signal is like when we are discussing about the network theory or circuit theory. So voltage we are represent as V of t. So voltage is a function of time. So it is only one variable. This V of t is one variable functions because this is only the function of time. So one variable signal this is. Next one is I of t. This is current. So current is also the one variable function that is function of time. Next one is x of t, that is the state variables. When we are discussing in the control system, that is x of t is the state variable, and sometimes we are defining it as displacements and some another the variable systems. Another examples are heartbeat sensors, multi blood pressures, temperature vibrations. These all are the examples of signals because all these examples give you some information. When we are discussing about the signals, so it may be, as earlier I am telling that it may be one-dimensional or multi-dimensional. So when we are discussing about the one-dimensional signals, so one-dimensional signal is that signal which is the function of only one variable. Either it is time, either it is displacement, either it is x, y, z, any coordinates. Only one variable should be there. So the best example for one-dimensional signal is your speech signal. The second one is multi-dimensional signal. So multi-dimensional signals, as the name indicated, it depend on the more than one variables. So it will be the two or three variables. It is a function of two or three variables. So multi-dimensional signals, the example of the multi-dimensional signal is the image signal. Next one, system. So what is system? So system is an entity or operators that manipulate one or more signals to accomplish a function. It means that system is nothing, but it will take some signals, one or more or multiple signals, and it will operate some function operations on that, and it will give you some output. So for the desired output, we are establish a system. So system is nothing, but it is the user defined or desired. So it gets some input signals, it operate on that signals, and it will give you the outputs. So system is that. The second one is that commonly encountered systems. So commonly encountered system are the communication systems, automatic speaker recognition systems, aircraft landing system. These all are the commonly encountered systems. The one more thing is that the signals, the basic of signals when we are discussing. So there are basic two types of signals. One is CT and other one is DT. So what is this CT and DT? So CT stands for continuous time signals and this DT stands for discrete time signals. So when we are discussing about the continuous time signals, so sir, what is continuous time signals? So continuous time signal are those signals which vary with respect to time at every instant of time. Means at every instant of time, it will change its amplitude or it will change the magnitude of the signals. The signals which are going to change its amplitude or magnitude at every instant of time, that is your continuous time signals. The second one is discrete time signals. So discrete time signals are those signals which give you the values which exist at the particular or integer value of time. It will not extend for all the value of time. It will only exist at the integer value of time. That is t equals to 1 second, 2 second, 3 second, 4 second, like that. If anybody tell you, okay, tell me what one discrete time signal is there, what is the value at 2.5 or 2.4? then we just say, sir, value will be 0, because discrete time signal can't be exist at the decimal value. Discrete time signal only exists at the integer value. So we have to remember that common difference between the CT and DT. Continuous time is valid at every instant of time, whereas discrete time is valid only at the integer value of time. So this is the difference between CT and DT signals. So next one, when we are going for the next one. So basically one relations will be there where also is there any relations that we have continuous time signal and we want discrete time signal from that continuous time signals. So is there any relations? Yeah, there will be one relations, and this process is known as sampling. So sampling is a process in which we are converting the continuous time signal into discrete time signals. So basically for many cases, we are defining the discrete time signal as x of n, and continuous time signal is x of t. This is the representations. So continuous time signal we are going to represent as x of t, and the discrete time signal we are going to represent as x of n. So in general, when we are defining the discrete time signal x of n, it is nothing but we are writing as x of nt, where n should be the integer 0, plus minus 1, plus minus 2, because it is defined only for the integer value. Now, I am already tell you that there are different type of signals there. So the first one, which is important, and also the important signals, that is even and odd signals. So what is even and odd signals? So first of all, first we are going to discuss about the even signal. What is even signal, sir? So first, at initial state, which we have some signal x of t. So one signal we have x of t. Now we are going to apply the reversible property, and we are finding x of minus t. So now we have two signals, x of t and x of minus t. If both the signal is same, x of t and x of minus t, both are same, it means they are even signals. Similar in discrete time domain, we are representing this x of n and x of minus n. So signals are even signals when x of t equals to x of minus t, or x of n equals to x of minus n. If this relation exists, then we can tell that signals are even signals. The second one is odd signals. So initially we have the signal x of t. Now we are going to reverse it. We get x of minus t. If x of minus t is equals to minus x of t, and x of minus n equals to minus x of n, then we can tell it is as odd signals. So these are the conditions for the even and odd signals. So first, only two processes are there. So first process, we have one signal x of t. So in first process, we are going to reversible it. We are going to replace t by minus t, and we are applying the reversible property. After that, we are getting x of minus t. Now compare x of t and x of minus t. If both are same, then we are telling that this is even signal. If x of minus t is negative of x of t, then we are telling that this is the odd signals. So if any signal x of t, if any signal is there x of t, it can be expressed as the combination of even signal and the odd signals. So x of t equals to x even of x e of t. It means x e of t means even part of xt, plus x o of t means odd part of xt. Similarly, x of minus t, x even part of t, xt, we are taking the even part of xt minus odd part of xt. Where xct we are telling you that there is the even part. Even part of xt means 1 by 2 x of t plus x of minus t. Similarly, x of t is the odd part of xt. That is given as 1 by 2 into x of t minus x of minus t. So these are even and odd signals are the most important signals in the domain of signal and system. Because in the next chapter, when we are discussing about the Fourier transform, Fourier series, there we are discussing about this even and odd. Because in Fourier transform, this is also again came in pictures that there is odd symmetry, even symmetry, half wave symmetry. So there we have to understand what is even and odd signal. If we understand what is even signal, what is odd signal, there it is easy to calculate the even symmetry, odd symmetry, and the half wave symmetry. So the next one is periodic and non-periodic signals. So these are the basic signals. From the class 10th, we are studied this thing, periodic signal or periodic signals. So this is the same what we are studying in before classes, that periodic signals are those signals So we are taking one signal x of t, so one continuous time signal, that is x of t. If x of t equals to x of t plus t naught, then x of t is periodic. It means where t naught is the fundamental period. So t naught will be the fundamental period. It may be some, it will be represented in some seconds. So after t naught second, it will repeat itself. Xt start repeating itself after the t naught second. Then we are telling that this is periodic signal. And what is the period, sir? That period is t naught. So fundamental period is t naught. Fundamental frequency. Frequency, we already know that frequency is the reversible of time. So 1 upon t naught. 1 upon t naught is your fundamental frequency. And fundamental frequency is represented in hertz or cycle per second. Third one is angular frequency. So angular frequency is given as omega naught. And omega naught, we already know that 2 pi f. Omega naught is 2 pi f. And in place of f naught, we are getting 1 upon t naught. So it is getting 2 pi by t naught. And the units is radian per seconds. It is represented as radian per seconds. Similarly, when we are discussing about the discrete time signals, so discrete time signals, we are representing x of n. So it is represented as x of n is equals to x of n plus n naught. So n naught is the fundamental period for the discrete time signals. Same fundamental frequency f naught, 1 upon n naught. Angular frequency is omega naught, that is 2 pi by n naught. And the angular frequency is represented as radian per sample. It is represented as radian per sample. One note is there, if addition of two periodic continuous time signals, if you have two continuous time signals and both the signals are periodic, and we are going to add both the signals. So new signal, we are assuming that x3 of t. So two continuous time signals, we have x1 of t, x2 of t. Both are periodic signals. Now we are going to add it, and new signal, we are forming x3 of t. So x3 of t, the new signal, may or may not be periodic. We can't say that this signal, if two signals are periodic and we are going to add it, then the resultant signal will be periodic. We can't say like that. We can say that it may or may not be periodic. But the second case, if the two signals x1 of n, x2 of n, discrete time signal we are taking. So in the second case, we are taking two discrete time signal, x1 of n and x2 of n. Now we are going to add it. And new signal we are going to form it is x3 of n. Then definitely x3n will be the periodic signals. So note, we have to remember that the sum of two periodic signal will be may or may not be periodic. But the sum of two discrete time signal will be periodic. So this note you have to remember for the futures and for the all questions when we are going to solve it. So next one is deterministic and random signal. As the name indicated, deterministic means determine. So deterministic signals means no uncertainty. There will be no uncertainty with respect to its value at any time. It means the value at any time of the signals we are assuming or we are understanding before. No need of that what will be the value at t equals to 2 seconds, 5 seconds, 10 seconds. We understand that. That signal are the deterministic signals. Whereas random signals are those which will change according to time. We can't define that at t equals to 2 seconds, if random signals is, we are taking x of t, at t equals to 2 seconds as 2. And we are assuming that t equals to 5 seconds, it will be 5. But it can't be because it is random. So it may be 10, it may be 15, it may be 12, any value it will take. So the random signal, the best example of the random signal is the thermal noise. Noise signal is the best example for the random signals. Next one is energy and power signals. So what is energy signals? Energy signals means we are interested in the energy of that signal. What is the energy of that signals? So we are taking one signal x of t, continuous time signal x of t. So energy is defined as integration minus infinite to infinite x square of t dt. So we are taking that area and we are going to square it. So we are taking x of t. So we are going to square of that signal and integrate up to minus infinite to infinite. It will give you the energy of the signals. Similarly, when we are discussing the power, so power we are getting find as limit t tending to infinity 1 upon 2t integration minus t to t x square t dt. This 1 upon 2t is the period in which interval we are going to take. the integrations. If we are taking the integration minus t by 2 to t by 2, then interval will be of t seconds. So then power will be getting limit t tending to infinity 1 upon 2, 1 upon t only. There will be not 2t because we are taking the interval between minus t by t to t by 2. So total interval is of t seconds. So limit t tending to infinity 1 upon t it will take. So one thing we have to remember that for any energy signals, if signal is energy, then the signal energy will be finite. If any signal which is energy signal, then energy will be finite and power will be 0. If signal is power signal, then power will be finite and energy will be infinity. So these 2 points A and B you have to remember for the energy and power signals. Similarly, when we are discussing about the discrete time signals, so similarly, discrete time signal, we are taking x of n. X of n we are taking. So for x of n, energy E is given as summation n minus infinite to infinite x square of n. And power is limit n tending to infinity 1 upon 2n plus 1 summation n minus n to n x square of n. So energy signals, definitely it will be finite. So energy will be lies between 0 to infinity. If power signal there, then power will be lies between 0 to infinity. So if signal is energy or power, then it should be finite values. So when we are discussing about the analog signal and digital signals, so there are 4 waveforms there. So first waveform, that is continuous time and continuous value. So this is the continuous signal. First one, we are discussing about the continuous signal. Why continuous? Because in amplitude it is continuous as well as in time it is continuous. So continuous signal are those signal which is continuous in amplitude as well as continuous in time. Second one is discrete time signal. So discrete time signal are those signal which is discrete in time as well as discrete in amplitude. Both the amplitude and time will be in discrete domain. The third one is digital. The last one signal is the digital signals. So sometimes we are going confused that discrete and digitals. So discrete signals and the one difference is there between the discrete time signal and the digital signals. So discrete time signal, in discrete time signal, amplitude as well as time, both are discrete in nature. Whereas in digital signals, amplitude are discrete, whereas the time is in continuous domain. Time is continuous and your amplitude will be the discrete. So this is the difference between the discrete time and the digital signals. So there are some operations what we are going to apply on the signals. So there are operations as amplitude scaling, additions, multiplications, differentiation, integration, time scaling, reflections, that is also known as time reversible property, time shifting, and the combinations of time shifting, time reversible, and the time scaling. All three we are going to combine it. So these are the different operations what we are going to apply on the signals. So these are the different mathematical operations what we are going to operate on the signals. So one question we are going to take that shifting and time scaling. So one signal we are going to take that yt equals to x of 2t plus 3 and xt is given as rectangular signal minus 1 to 1. So this is combination as shifting as well as scaling. So this is the this question consists 2 operations, shifting by 3 units, that is 2t plus 3. Plus 3 is the shifting, what we are going to shift the signal by units, and 2t, that is the scaling. So we are going to scale by 2 units in the time domain. So we are taking one signal x of t, that is the rectangular signal minus 1 to 1. So what we are going to do, we are going to shift it by 3 units. When it is plus 3, plus 3 means we are going to advance the signal. So if it is plus 3, it means it is advanced the signal. If it is minus 3, then we are telling that it is delaying the signals. So this is plus 3, so we are going to advance the signal, means we are going to shift the signal by 3 units in the left hand side. When we are going to shift it by left hand side by 3 units, so this one getting minus 2 and this minus 1 getting minus 4. So we are getting x of t plus 3. And the next one, x of 2t. When we are applying the 2t, it means we are going to scaling it. So it means scaling it time domain. What is the instant, time instant? We are going to divide it by that scaling factor, that is 2. So minus 4 now getting minus 4 by 2, it is getting minus 2. And minus 2 divided by 2, it is getting minus 1. So x of 2t plus 3, we are getting the rectangular signal between minus 1 to minus 2. So next one is the type of signals. So different type of signals are there. So there are exponential signals. Exponential signals are those that is the continuous time and discrete time. So exponential signal, we are already understand that it will be in the term of e to the power something. So we are taking xt equals to b e to the power 80, where a and b are the reals. So if a is less than 0, it is decaying signal. If greater than 0, growing signal. If it is equals to 0, then we are getting the DC signals. Second one is the sinusoidal signals. So sinusoidal signal is given as a cos omega t plus phi. And similarly in discrete domain, it is given as a cos omega n plus phi. So these are the two different type of signal which we are going to discuss in signal system. That is exponential signal and sinusoidal, and sometimes we are telling it as trigonometric signals. So sinusoidal or cosine signals. Next one is unit impulse function. So one of the most important type of signals which we are going to discuss is unit impulse function. So unit impulse function, what is unit impulse function? So first of all, unit impulse function in continuous time domain, it is represented as del of t. So del of t equals to 0 when t is not equals to 0. And del of t equals to 1 when t equals to 1. Sometimes we are going to confuse that this is 1. What is this 1, sir? So this 1 is nothing but the area of the signal. This 1 is the area of the signal. So it is represented as minus infinite to infinite integration del t dt. So this is area of the signal at t equals to 0 equals to 1. In discrete time domain, it is represented as del of n. So del of n equals to 1 when n equals to 0. That is the area. And 0 when n equals to not 0. The second important signal are unit ramp signal. Unit ramp function, this is represented as R of t. So R of t equals to t ut. Ut is the unit step functions. So it is represented as t ut when t greater than 0 and 0 when t less than 0. So this is your ramp functions. So first of all, we are going to discuss about this one. So one function is there, x of t. We are taking one input signal, x of t. We are applying on the system whose impulse response is h. We are represented this as h, system function as h. And after passing through h, we are getting some output y of t. Similarly, in discrete time domain, we are taking the discrete signal, input discrete signal as x of n. We are applying on the systems whose function, transfer function is h, and it is given as y of n. So h represents the system, x of t, we are applying the function as h, system parameter that is h, and we are getting the y of t. So x of t is your input, y of t is your output. So the second one is stability. So first of all, when we are going to discuss about any signals, so first of all, we are discussing about the stability. Is it stable or not? Because when we are discussing any system, so we want every time that system should be stable. If system is stable, then it will be for long lasting. So how we find the stability? So for stability, it follow that BIBO. BIBO means bounded input, bounded output. If the BIBO is satisfied, it means system is stable. So one signal is there, m of x. So m of x lies between the magnitude of xt and less than infinity. It means the value of magnitude of xt should be finite. Then we can tell it is the stable signal. Second one is memory and memoryless systems. What is memory and memoryless? So memory system. First of all, we are discussing about the memory system. If system, we are taking one systems. If the present output depend on the past as well as future input. If we are taking one system whose present output depend on the past or future inputs, then we can telling that this system is memory system because it depends on the past input. So when the system will depend on the past input, we are telling that system is memory system. And memory-less system, when the present output value depend only on present input, when the present output depend only on present input, then we are telling that this is the memory-less system. It doesn't depend on the future or past value. So this is the memory-less system. It always operates in the present values. So one example we are taking that memory system. So y of t equals to 5x of t plus integration minus infinite to t x tau d tau. So tau value is lies between minus infinity to t. When we are taking from minus infinite to t, it means we are taking the previous value. When we are taking the previous value, it means it has some memory. So this example of the memory system. Second one, memory-less system. When we are discussing the memory-less system, so in that system, we are discussing y of n equals to x of n plus x square of n. So when we are taking n equals to 5, it will x of 5 plus x square of 5. If we are taking n equals to 6, x of 6, x square of 6. So it depends only on present value. So this is known as the memory-less system. Next one is causal and non-causal system. So what is causal system? So first of all, causal system are those systems in which present output depend on present and past value of input. Causal system are those systems in which the present output depend only on present as well as past value of input. Then it is causal system. The second one is non-causal. Non-causal is which type of system is non-causal? So non-causal systems are those in which the present output depend on the future value of input. Then we are telling that this is the non-causal system. So it means the causal system present output depend on the past as present and past value of input. So memoryless system are causal system. All memoryless system are causal system, but all the causal systems are not the memoryless system. So when we think, we have to remember that memoryless system is always the causal system, but causal system may or may not be the memoryless system. Because the memoryless system, what is memoryless system? It depends on the present output depend on the present input. So it only depends on the present input. So memoryless system can be the causal system, but causal system may not necessarily be the memoryless systems. Next one is the time invariance. What is time invariance? So time delay or advancement of the input. It means an identical time shift in the output. If we are going to time shifting in the input, then same time shifting will occur in the output. Then we can tell it is time invariant system. So let us define a system as y of t equals to h of xt. System is time invariant if x of t minus t naught equals to y of t minus t naught. So if we are going to delay the signals x of t minus t naught and same delay will be provided in the output, then we can tell it as the time invariant system. Otherwise, it will be time variant. If it is not followed, then it will be time variant system. Next one is linearity. What is linear system, sir? So linear system, we are taking that if x1t output is y1t, x2t output is y2t, then ax1t plus bx2t output will be ay1t plus by2t. Then it will be linear system. Otherwise, it will be non-linear. So two things we have to remember for linear system, that it will follow the superposition theorems or superposition property, and second one is homogeneity property. If any signals follow this superposition and homogeneity, then we can tell it as linear system. Otherwise, non-linear system. Invertibility. What is invertibility? So we are applying some signal x of t. It is applying on h. Then it is applying on h inverse. It is applying on h. It will applying on h inverse. Then we are getting some output. Output will be same as the input. So system will be invertible if system produce different output for different input. So system is invertible system if system produce different output for the different inputs. We are applying the different inputs, then output will be different. If we are applying the different inputs and output will be same, it means system is not invertible. If we are applying different input and output is also different, in that case, we are telling that system is invertible. So there are some interconnections in the signal system. First one is series or cascade interconnection. So series or cascade interconnection means we are taking two systems, system 1 and system 2. We are connected, it is in series. So when we are applying this and we are getting this series connections, so we are assuming that system 1 gain is Z1 and system 2 gain is Z2. When it is come in cascade or series connection, then the overall gain of the system will be multiplication. So it will give you the overall gain will be G1 into G2. It will multiply. Second one is parallel connection. So parallel connection, if system 1 has gain G1 and system 2 has gain Z2. If it is connected in parallel connection, then the output or we can tell it as the equivalent gain of the system, it will the addition G1 plus G2. So you have to remember, if the system are in cascade or series, then in that case gain is multiplication, gain will be multiplied. If the system are in parallel connections, in that case gain will be the additions of the individual gains. The third one is the feedback interconnection. These are the most important feedback interconnections, because from these feedback interconnections, we are getting the desired output. So this is the backbone for the control systems. When we are discussing about the control systems, then this feedback interconnection is the backbone of that control system. So this feedback system will give you the desired output. So we are assuming system 1 and system 2. So system 2 is the feedback path. So system 1 is the forward path. The system 1 is the forward path. System 2 is the feedback path. So we are assuming system 1, that is the forward path, gain is G, and system 2, that is the feedback path, has gain as H. So it is negative feedback or positive feedback. There are two feedback are there. So this is maybe negative or positive. Then we are defining the transfer function. So transfer function will be given as GH upon 1 plus GH. So that is the combinations of the feedback connections. It may be either negative feedback, positive feedback. That depend. According to that, we are applying the transfer function formula. That is given as gain of the forward path divided by 1 plus or minus. Plus or minus depend on the forward, that is your negative feedback or positive feedback. If positive feedback, then we are writing negative sign. If it negative feedback, then we are writing the positive sign. So gain of the forward path divided by 1 plus or minus for gain of forward path multiply with gain of the feedback path. So it is the formula is given as G upon 1 plus minus of GH. So this is the basics of the signal system, in which we are going to discuss different type of signals, different type of systems in which we are going to operate, and different mathematical operations which we are going to operate on the signals, like time shifting, time scaling, time reversible, addition, multiplications of the signals. So these are the basics of the signals. So for tomorrow class, thank you.